This restless Yellowstone caldera is truly living, breathing. Every once in a while, it burps.
The Yellowstone caldera, often referred to as the Yellowstone supervolcano, is a geological marvel nestled in the heartland of America. Its beauty belies the intense volcanic activity simmering beneath its surface, activity that could erupt with little warning, impacting the globe in innumerable ways.
If it erupts in a maximum eruption called Category 8, it can literally tear the guts out of the United States of America.
Now let's delve into the signs that hint at the imminent awakening of this dormant giant. Number 1. The geological instability of Yellowstone. Yellowstone's geographic foundation sits on a hotbed of geological instability. The existence of the Yellowstone caldera itself is the result of multiple massive volcanic eruptions, the most recent of which occurred approximately 640,000 years ago. These eruptions have shaped the landscape and underscore the potential for future volcanic activity. Underneath the national park lies one of the world's largest magma chambers, extending from the crust down to the upper mantle. It is this reservoir of molten rock that fuels Yellowstone's geysers and could potentially fuel another catastrophic eruption. Geological studies show that this magma chamber is slowly rising, indicating the increased pressure within it. Moreover, the North American tectonic plate upon which Yellowstone lies is moving southwest over a stationary hotspot in the Earth's mantle. This results in a continuous pressure that, with time, has the potential to trigger an eruption. As the crust is forced over the hotspot, it melts and forms magma, further exacerbating the tension. This inherent instability is also reflected in the frequency and intensity of seismic activity in the region. Yellowstone experiences between 1,000 to 3,000 earthquakes annually, though most are too small to be felt at the surface. However, these earthquakes signify a constant readjustment of stress in the Earth's crust caused by the movement of magma and tectonic forces. Additionally, a study by the University of Utah revealed that the magma reservoir beneath Yellowstone is nearly 2.5 times larger than previously believed. This finding emphasizes the magnitude of the potential risk associated with a supervolcanic eruption. Recent measurements also show that the ground in the Norris Geyser Basin, the hottest and most dynamic thermal area in Yellowstone, has been rising at an unprecedented rate. This uplift suggests a change in the hydrothermal system beneath it, possibly due to the influx of magma. Given these factors, it is clear that the geological structure and processes at Yellowstone contribute to a volatile and unpredictable environment. While these aspects do not necessarily signal an immediate eruption, they serve as reminders that Yellowstone is far from being a stable geological feature. The lurking uncertainty that arises from these observations makes it crucial to continually monitor Yellowstone's activity to better predict its behavior and mitigate potential hazards. Despite the absence of any immediate signs of an eruption, the factors highlighted here underline the inherent instability of the Yellowstone supervolcano. This instability, coupled with the vast scale of the magma chamber and the potential for sudden changes in the volcano's behavior, underscore the reasons why an eruption could occur at any moment. Number 2. The earthquake connection. Earthquakes are a prominent feature of the Yellowstone region. They occur as the result of complex geologic processes associated with the movement of the Earth's tectonic plates and the accumulation of magma beneath the park's surface. This seismic activity often serves as an indicator of potential changes in volcanic behavior, which makes understanding the earthquake connection crucial when contemplating the potential for a Yellowstone eruption. Every year, Yellowstone experiences thousands of small earthquakes, most of which are too weak to be felt at the surface. These minor tremors are generally harmless, but they provide scientists with invaluable data about the subsurface movement of magma and other geological changes. More noteworthy are the earthquake swarms, sequences of earthquakes striking in a specific area within a short period of time. These swarms can last for days or even months, and often represent an increase in subsurface activity. A well-documented case of such activity is the 1985 swarm, which was one of the most extended and intense ever recorded in the park, leading to heightened concern among geologists about a possible impending eruption. While no eruption followed this swarm, it emphasized the possibility that increased seismic activity could potentially precede an eruption. Another significant event occurred in 1959 when a 7.3 magnitude earthquake hit Hebgen Lake, located just outside the western boundary of Yellowstone. This earthquake triggered a massive landslide and caused significant changes to the park's geothermal system. If a similar earthquake were to occur today, particularly closer to or directly beneath the Yellowstone caldera, it could have substantial implications for the stability of the underground magma reservoir. Such seismic activities can alter the balance of forces in the crust, possibly leading to magma movement. If the magma reservoir's overpressure, pressure higher than the rock can sustain, reaches a critical point, it can fracture the rock, generating pathways for the magma to ascend to the surface, resulting in a volcanic eruption. The recurring and significant seismic activity in and around Yellowstone is, therefore, a vital factor to consider when examining the likelihood of a future volcanic eruption. While it is essential to remember that not all seismic activity signifies an imminent eruption, the link between earthquakes and volcanic eruptions is well documented. As such, an increase in the frequency or intensity of seismic activity at Yellowstone could suggest changes in the subsurface that merit close attention and could potentially signal an impending eruption. Number 3. The heat beneath, geothermal dynamics. The geothermal dynamics of Yellowstone National Park are a direct reflection of the intense volcanic activity lying beneath its surface. Yellowstone is home to one of the world's most prolific geothermal systems, hosting over 10,000 geysers, hot springs, and other thermal features. Understanding these geothermal dynamics can provide insights into the subsurface processes and possible signs of an impending volcanic eruption. The geothermal energy in Yellowstone comes from the residual heat of the vast magma chamber situated beneath the park. This heat rises to the surface, warming the ground and the water in the region, leading to the formation of geysers, hot springs, and other geothermal features. An increase in geothermal activity may suggest an increase in the heat flux from the magma chamber, potentially indicating the upward movement of magma. One visible indicator of geothermal activity is the surface temperature. Satellite imagery over the years has shown areas of elevated temperatures within the park, a clear sign of strong geothermal activity. Notably, these thermal anomalies can change over time, aligning with seismic activities, and these changes may offer clues to the potential volcanic unrest beneath the park's surface. Steamboat Geyser, the world's tallest active geyser located in Yellowstone, is another noteworthy feature. Its unpredictable eruptions are a spectacle and a testament to the park's geothermal energy. A significant increase in the frequency of its eruptions has been observed in recent years, which could be an indication of changes in the subsurface hydrothermal system connected to the magma movement. The geyser's activity, heat flux, and changes in the geothermal features are directly influenced by the state of the underlying magma chamber. Hence, a significant shift in geothermal activity could be one of the possible precursors to an eruption. Yellowstone's geothermal dynamics is also closely connected to seismic activity. Seismic waves can open up new pathways for the hot fluids to rise to the surface, leading to changes in geyser activity or the formation of new geothermal features. Such occurrences were recorded after the Hebgen Lake earthquake of 1959, underlining the interdependence of seismic and geothermal activities. While geothermal dynamics alone cannot predict a volcanic eruption, it forms a crucial component of the overall understanding of the Yellowstone system. By closely monitoring the geothermal features and understanding their connections to the processes happening beneath Yellowstone, scientists can gain a better picture of the ongoing activity within the magma chamber and the potential risks associated with it. As such, the geothermal dynamics of Yellowstone represent another reason why the supervolcano could erupt at any time. Number 4. Rising ground level. Evidence of magma movement. One significant indicator of potential volcanic activity at Yellowstone is ground deformation, particularly ground uplift. The rise and fall of the Earth's surface in and around the Yellowstone caldera is a testament to the restless nature of the magmatic system beneath the park. Monitoring ground deformation can provide valuable insights into the movement of magma and the state of the magma chamber, thus giving us another reason to believe that Yellowstone could erupt at any time. Ground deformation at Yellowstone is primarily driven by changes in pressure in the subterranean magma chamber and the associated hydrothermal fluids. When there's an influx of magma into the chamber, it increases the pressure, causing the ground above to bulge upward. Conversely, when the magma chamber depressurizes, the ground can subside. Recent years have seen considerable uplift in areas around the Norris Geyser Basin, the most thermally active region of Yellowstone. Between 2013 and 2015, for instance, the ground around Norris rose by approximately 6 inches. This uplift was one of the most rapid and significant deformation events observed at Yellowstone, suggesting an increase in pressure due to the influx of magma or hydrothermal fluids. Scientists use various methods to monitor ground deformation at Yellowstone. These include GPS stations scattered across the park, satellite radar images, INSAR, and leveling surveys. These techniques can precisely measure changes in the ground level, often down to a few millimeters. Such continuous monitoring has revealed that ground deformation at Yellowstone can vary over time and across different locations, indicating the complex and dynamic nature of the subsurface processes. In another instance, the caldera floor was observed to rise by nearly 3 feet between 2004 and 2010, one of the most significant uplift episodes recorded since monitoring began. Although this intense uplift was followed by a period of subsidence, it served as a stark reminder of the active magmatic system beneath the park. While ground deformation is a common phenomenon in volcanic regions worldwide, the rapid and considerable ground uplift at Yellowstone is particularly noteworthy given the sheer size of the underlying magma reservoir. Though uplift alone does not imply an imminent eruption, a sudden or significant increase in uplift, especially when coupled with other indicators like increased seismic or geothermal activity, could signify a disturbance in the magma chamber that might precede an eruption. Therefore, the rising ground level as evidence of magma movement stands as a potent sign of the potential for Yellowstone's volcanic activity. The ongoing ground deformation reflects the volatile and active nature of the magma system beneath Yellowstone, reinforcing the notion that the supervolcano could indeed erupt anytime soon. Number 5. Increased geyser activity. Geysers serve as surface expressions of the intense geothermal activity occurring deep beneath Yellowstone National Park. Their frequency and vigor of eruptions offer a window into the dynamics of the underlying magma system. An unusual increase in geyser activity could thus hint at potential changes occurring beneath the surface and may signal an impending volcanic eruption. Yellowstone boasts more than 500 geysers, the most famous being Old Faithful, renowned for its predictability. However, even the faithful Old Faithful has seen slight changes in its eruption intervals over the years, subtly hinting at the shifting dynamics beneath the surface. Steamboat Geyser, the tallest active geyser in the world, has shown significant changes in its activity. Historically known for its infrequent but powerful eruptions, Steamboat remained relatively quiet for decades. However, since 2018, it has been erupting with surprising regularity. Such a drastic change in behavior indicates an alteration in the subsurface hydrothermal system, which could be due to changes in the magma reservoir. Geysers are formed when underground water is heated by the magma body and begins to rise to the surface. If the path is blocked, pressure builds up until it's strong enough to force the water upward, causing a geyser eruption. An increase in geyser activity could mean that more heat is being released from the magma chamber, potentially indicating magma movement. Besides the major geysers, scientists also keep a close eye on changes in smaller geysers and geothermal features, as these could also signal a shift in the underground dynamics. For example, the formation of new geysers or the reactivation of dormant ones could suggest new pathways for heated water to reach the surface, possibly due to seismic activity or magma movement. To monitor these changes, researchers use various instruments, including temperature sensors and seismometers. They also use satellites to capture thermal images of Yellowstone, providing a comprehensive view of the park's thermal behavior. While increased geyser activity is not a guaranteed sign of an imminent eruption, it does indicate a shift in the underlying geothermal system.
Water was drawn off, it changed the dynamics.
This, combined with other indicators like seismic activity and ground deformation, could provide critical clues to the state of the magma chamber. Therefore, the increased geyser activity at Yellowstone presents yet another reason why the supervolcano could potentially erupt at any time. It serves as a reminder of the active and volatile nature of Yellowstone's geothermal system, which is directly linked to the simmering magma reservoir beneath. A close observation of these geothermal marvels is therefore imperative to understanding and potentially forecasting Yellowstone's volcanic behavior. Number 6. Changes in hydrothermal reservoirs. The hydrothermal reservoirs of Yellowstone National Park are large underground systems containing hot water and steam, created by heat emanating from the magma chamber. Any changes in these reservoirs can be indicative of alterations in the deep geological processes, offering further insight into the possibility of an imminent volcanic eruption. Hydrothermal reservoirs play a crucial role in Yellowstone's geology, directly influencing the park's extensive network of geysers, hot springs, mud pots, and fumaroles. Changes in these reservoirs can manifest in several ways, including alterations in the temperature and chemistry of hot springs, new or reactivated thermal features, and increased geyser eruptions. One of the most significant changes that can occur in a hydrothermal reservoir is an increase in pressure. This can be caused by an influx of magma into the chamber, a rise in the heat supplied by the magma, or seismic activity creating blockages in the plumbing system. The increased pressure can lead to more frequent or intense geyser eruptions and other changes in geothermal features. Another way changes in hydrothermal reservoirs can be detected is through water chemistry. The heated water in these systems dissolves minerals from the surrounding rocks. As such, the mineral content of the water in geysers and hot springs can offer clues about changes in the hydrothermal system. A sudden or substantial change in water chemistry could signal a disturbance deep within the reservoir. The Norris Geyser Basin provides a notable example of changes in a hydrothermal reservoir. The ground level in this region has been rising rapidly over the past years, a phenomenon linked to changes in the hydrothermal reservoir beneath. This uplift, coupled with increased geyser activity and changes in the water chemistry of local hot springs, suggests significant changes in the hydrothermal system, possibly related to the movement of magma. Monitoring the hydrothermal reservoirs is a complex task, requiring a combination of ground-based observations and satellite imaging. This data, when coupled with seismic information and ground deformation measurements, can provide a comprehensive picture of the state of the hydrothermal system and its potential implications. Number 7. Anomalous gas emissions. Volcanic gas emissions provide important insights into the magmatic processes occurring beneath the surface. In Yellowstone National Park, the monitoring of gas emissions, particularly carbon dioxide, CO2, and sulfur dioxide, SO2, is a critical component of assessing the state of the underlying magma chamber. Anomalous or sudden increases in these emissions could signal changes in the magmatic system, potentially indicating a forthcoming eruption. The bulk of gases emitted by Yellowstone are water vapor, steam, and carbon dioxide, with minor amounts of sulfur gases and other trace elements. These gases originate from the magma, escaping to the surface through cracks in the Earth's crust and the park's geothermal features. CO2 is the second most abundant gas emitted by volcanoes, and its levels can hint at changes in the magmatic system. Yellowstone emits a substantial amount of CO2, with estimates suggesting that about 45,000 tons of the gas are released every day. A sudden or significant increase in CO2 emissions could indicate an upwelling of magma, as fresh magma releases more CO2 compared to the older, degassed magma. SO2 is another key volcanic gas. While SO2 emissions at Yellowstone are generally low due to the extensive hydrothermal system scrubbing out most of it, any significant increases in SO2 levels could suggest new magma entering the system. Monitoring these gases involves ground-based measurements and satellite observations. Ground-based instruments like gas sensors and spectrometers measure gas concentrations directly. In contrast, Satellites can provide a broader view of gas emissions across the park. Combining these measurements allows scientists to track changes in gas emissions and identify potential anomalies. Changes in gas emissions were observed during periods of increased seismic activity and ground deformation at Yellowstone, suggesting a connection between these events and the subsurface magmatic processes. While increased gas emissions alone are not a surefire indication of an impending eruption, they can provide critical information when considered alongside other geophysical data. For instance, an increase in gas emissions accompanied by heightened seismic activity and ground uplift could indicate a significant disturbance in the magma chamber, possibly preceding an eruption. Number 8. Crustal deformation trends. Crustal deformation refers to changes in the Earth's crust due to tectonic forces. In the context of Yellowstone, these changes are closely monitored as they can offer valuable insights into the dynamics of the underlying magma chamber and the associated seismic activity. Recent crustal deformation trends at Yellowstone serve as another compelling reason why the supervolcano might erupt anytime soon. Ground deformation, as a component of crustal deformation, is commonly observed at Yellowstone. As discussed earlier, this deformation often comes in the form of ground uplift and subsidence, which can be caused by changes in pressure within the magma chamber or the movement of hydrothermal fluids. Persistent or significant ground uplift may suggest an influx of magma into the chamber, which could potentially lead to an eruption. However, crustal deformation trends extend beyond simple ground uplift or subsidence. For example, larger-scale tectonic movements and the release of accumulated tectonic stress can also cause changes in the Earth's crust, potentially affecting the dynamics of the magma chamber. Seismic activity is another aspect that can cause and result from crustal deformation. Earthquakes can induce changes in the Earth's crust and alter the pathways for magma and hydrothermal fluids. On the other hand, movement of magma or fluids can generate seismic events. A trend of increasing seismic activity, coupled with notable ground deformation, could indicate significant changes in the magma system. Number 9. Yellowstone's volcanic history, a tale of frequent eruptions. One of the key factors informing the potential for an eruption at Yellowstone is the park's volcanic history itself. Looking back over geological time, Yellowstone's past is punctuated with frequent eruptions, underlining the volatile nature of this geologically active region. This history of eruptive activity points towards the possibility of future eruptions, constituting another reason why Yellowstone could erupt anytime soon. Yellowstone has experienced 3 major caldera-forming eruptions in the last 2.1 million years. These eruptions were massive in scale, each one ejecting over 1,000 cubic kilometers of material and creating the expansive Yellowstone caldera, which spans about 34 by 45 miles. The most recent of these eruptions occurred around 640,000 years ago, creating what is now the Yellowstone caldera. However, Yellowstone's volcanic history extends beyond these major eruptions. The park has also witnessed numerous smaller eruptions since the last caldera-forming event. The most recent volcanic activity in Yellowstone occurred about 70,000 years ago with a lava flow in the Pitchstone Plateau area. In addition, about 80 non-explosive eruptions have filled the caldera with extensive lava flows, the last of which occurred about 70,000 years ago. Moreover, the area has experienced a series of notable hydrothermal explosions over the past 15,000 years. These events are triggered when superheated water turns rapidly into steam, causing a violent explosion. The resulting craters, such as Mary Bay and Indian Pond, serve as reminders of the potential explosive power of Yellowstone's hydrothermal system.
Over the past week or so, we have seen a shift to more sustained diffusion at higher diffusion rates.
Scientific research into Yellowstone's past helps inform predictions about its future. By studying the remnants of past eruptions, scientists can gain insights into the processes leading up to these events and the potential signs of an impending eruption. While predicting the exact timing of an eruption remains beyond current scientific capabilities, the historical data is valuable in estimating probabilities and understanding the possible scale and impacts of future eruptions. Number 10. Climate change impacts on volcanic activity. The potential influence of climate change on volcanic activity presents yet another reason why Yellowstone could potentially erupt soon. While the connection between climate change and volcanism is complex and still a topic of ongoing research, certain mechanisms suggest that alterations in climate could potentially induce volcanic eruptions. One of the ways climate change could impact volcanic activity is through changes in surface load. As the climate warms, glaciers and ice caps melt, reducing the weight on the Earth's crust. This unloading process can lead to crustal rebound, where the Earth's crust adjusts to the weight reduction. This adjustment can, in turn, cause stress changes that might trigger volcanic eruptions, especially in volcanically active regions. Yellowstone, though not covered by large ice masses, could still be affected by such mechanisms. The park's geothermal areas are often covered by heavy snow in winter, and the melting of this snow during spring could lead to minor surface load changes. While these changes might not be as significant as glacier melting, they could still contribute to stress changes in the crust. Climate change can also affect the hydrothermal system of Yellowstone. Warmer temperatures and changes in precipitation patterns can alter the amount of water entering the system. Given the crucial role of water in maintaining Yellowstone's geysers and hot springs and influencing the behavior of the magma chamber, such changes could potentially impact the park's volcanic activity. It's important to note that the relationship between climate change and volcanic activity is complex and not fully understood. While the mechanisms described above suggest a potential connection, more research is needed to quantify this relationship and understand its implications fully.